So we have covered, different aspects in the last class. So we'll be moving with, questions today. So we have planned with, different types of questions for the examination point of view. So we'll cover that in today's lecture. So here are different questions. So we'll look at different questions and the approaches to solve them. So here comes the first question on the screen. Yeah, I hope I'm audible. Again, reconfirming. A body of mass m moving along a straight line covers half the distance with a speed of 2 meters per second. Okay, and the remaining half of the distance is covered in two equal time intervals with a speed of 3 meters per second. Okay, 3 meters per second and 5 meters per second. So it's covering in two different instances. The average speed of the particle for the entire journey for the entire journey is, so we have different options here. First one, option 3/8 meters per second, and option B 8/3 meters per second, and option C 4/3 meters per second, and option D is 16/3 meters per second. Fine. So these are the possible options that we have. So we'll need to approach this question and solve it. Okay. So based on the given question, what is the data we have? We understand that the motion, the object is moving in a straight line. It's covering half of the distance with a speed of 2 meters per second. So you have 2 meters per second first, which is the speed for the first half of the journey. Wherein the remaining journey, the distance covered in two equal time intervals with, say, a speed of 3 meters per second and 5 meters per second. Okay, the speed is different. All right, but the time intervals are being equal. So having this information, you will have to calculate what is the average speed. So let's look at how to approach this particular question. Okay, there is a step-by-step approach. So whenever you have questions based on average speed, you can make use of this particular method to solve them very easily. Okay, we'll see the solution now. Okay. So first aspect, if you see, let us take the total distance covered by the body as, you know, x. So say the total distance covered by the particle from A to B is x. This entire distance we take it as x meters. Okay. Now say half of the journey we have a midpoint O. So O is the midpoint of AB, where AB is the entire distance covered by the object. Okay. So AO is half of it and OB is also going to be half of it. So AO equals OB. So both of them are equal because O is the midpoint of AB. Having this in mind, let us say both are equal. So because both are equal, so we can take this as distance, this distance as D, and this distance is also going to be D, such that 2D is the total distance because both of them are equal. So if we take 2D as the total distance, then what is the time taken by the object to cover first half of the journey? We can write down the time as, okay, T1 as the distance traveled for the first half. So you can take it as D upon 2. Okay, because it is covering first half of the journey. So having this in mind, you can say T1 is equal to D by 2. Similarly, the total distance, we can write the total distance is nothing but 2D, can be expressed as, okay, you can express this particular, total distance as S is equal to, okay, we have used the letter X, so let me use X as well. Okay, so we can say X is equal to, now what about the distance traveled from O to B? You can see we have two speeds which are there, which is 3 and 5 meters per second. So that is for the next half from O to B. So from O to B, let me put it that way, from O to point B, that is for OB, we can say the distance traveled is nothing but speed into time, making use of that particular relation. So I can go back and write this as 3 into T2 plus, I can write it as 5 into T2, because since distance traveled is equal to speed into time. So making use of this particular relation, I am writing OB is equal to 3T2 plus 5T2. So we can write it like this particular relation. So you can take a common out here. So you will get this as 3T2 plus 5T2 is basically 8T2. Okay, and OB is equal to D. Okay, so I'm going and substituting that particular relation. So T2 is equal to D upon 8. So I'll get the relation like this, seconds. So T2 is D upon 8 seconds. And we already got T1 is equal to D upon 2 seconds. Okay, we have got the total time now, which is T1 plus T2. Individually, if you have, and then if you want total, you're just going to add them. Now, by using the formula for average speed, which is total distance traveled divided by total time taken, make use of this particular relation. So total distance traveled, we already know the total distance is equal to 2D upon total time taken is T1 plus T2. Let me go and substitute. So what do I get by substituting? I can write this as 2D upon T1 is basically D upon 2 plus T2 is D upon, I suppose it's 8. Yeah, we have calculated that. So it's D upon 8. Go for a simplification. Okay, you can take basically, D as common out and cancel them. So you can write this as 2D Within brackets in the denominator, take d as common. So 1 upon 2 plus 1 upon 8. So d and d will get cancelled off. Take the reciprocals, children, and then go for a simplification. Okay, so you will get the answer as 8 upon 3 meters per second, and that's the value of average speed. Okay, so therefore the answer for average speed is 8 by 3 meters per second. And what's the answer according to our question? The answer is option B, which is 8 upon 3 meter per second. I hope it's clear. So this is how you'd go for a step-by-step approach to solve this question. Okay, so this is the approach, children. So that's the reason I explained it. So such questions are again crucial. The approach should be very clear. Okay, different way the questions can be asked. Okay, so this is one particular method that we have seen. So without any further delay, we'll go to the next type of question, children. So here comes the next question. The second question. Question number 2. Here we go. Yeah, a particle starts its motion from rest under the action of constant force. Okay, under the action of constant force. If the distance covered in the first 10 seconds is S1 and that covered in the first 20 seconds is S2, then you have the options as option A, S2 is equal to 3S1, option B, S2 is equal to 4S1, option C, S2 equals S1, and option D, S2 is equal to 2S1. Okay, so these are the options. Okay, from this question, what do you understand? You can see that the particle is starting its motion from rest, which you understand that initial velocity is 0 under the action of a constant force. Okay, so the distance covered in the first 10 seconds, they have given it as S1, and in the first 20 seconds, they have given it as S2. So given these relations, they are asking you what are the relations between S1 and S2. So you'll have to calculate what's the relation between S1 and S2. Okay, so how do we do that? Make use of the equations of motion. You can see based on the question what is the given data. Okay, so distance covered in first 10 seconds. How much is the distance covered in the first 10 seconds? As per the question, you can see it is S1, right? So we can write S1 is equal to UT plus half AT squared is the formula. So S is equal to UT plus half AT squared. Make use of this relation, children. What do you get? You will get S1 is equal to initial velocity is 0. So you will get half into acceleration. You don't know acceleration, take it as A. T square is 10 squared, which is 100. So what is the value you will get? You get S1 is equal to 50A, right? So 50A is the value. Just cancel it off. So S1 is equal to 50A is the first relation. Who can tell me what is the distance covered in the next 20 seconds? The same logic can you use and tell me what would be the answer? What would be the value? Distance covered in next 20 seconds. Okay. So what do you get that? And value as, you can write S2 is equal to half A into T squared, which is 20 squared. I can write it as 20 times 20. So cancel it off. So you will get this as S2 equals 200A, right? That is the second equation. Now you need to equate both S1 and S2. Equate them, children. Equate for acceleration. Okay? So when you equate them, what do you get? Or you can also go for a division. Okay? So what happens? If you do 1 upon 2, you get S1 upon S2 is equal to A would get cancelled off. Okay, anyways, I'll write it and then I'll show you the cancellation. So 50A upon 200A. A is cancels, 0, 0 cancel, 5 ones are, 5 fours are. So you get S2 is equal to 4S1. That's the relation. Is it clear? So you get S2 equals 4S1. And what's the option? The correct answer is option B. Okay, S2 is equal to 4S1. And that's how you solve this question. All right. So that's the approach, children. I hope it's clear. So we'll go to the next question now. Question number 3. Okay, this is another type of question, a different model altogether. Let us see how to do this. Okay, here we go. A bullet is fired vertically upwards with an initial velocity of with an initial velocity of 50 meters per second. It covers distance h1 during the first second and a distance h2 during the last 3 seconds. Okay, during the last 3 seconds. If g is equal to, that is acceleration due to gravity, they've given you to take the value as 10 meters per second squared, then h1 and h2 will be related as, now here you have the options. The first option, that is option A, is h1 is equal to 3h2. Option B, h1 is equal to 2h2. Option C, h1 is equal to h2. And option D, h1 is equal to h2 upon 3. So these are the options that you have. So given the following options, you'll have to identify the right one. So read the question carefully and then you will have to make a wise choice. Okay. So how do we, basically approach this question? Again, try to understand the given scenario. Read the question. A bullet is fired vertically upwards with an initial velocity of 50 meters per second. So you have some initial velocity, right? Which is 50. It covers some distance, that is h1, during the first second. and h2 distance during the last 3 seconds. Now, having this information, you will have to relate h1 and h2. Okay, so you need to relate it. So first, let's try to find out what is the total time taken by the bullet, okay, to reach the highest point. So let's try to find out. Okay, so the total time taken by bullet to reach maximum height, okay, or highest point. Okay, maximum height. We'll take it as t. So t is equal to u upon g because it's traveling upwards. That is, so acceleration due to gravity will come into picture. Okay, so we can write this as 50 because initial velocity was given as 50. Acceleration due to gravity is 10. Simplifying, you will get t is equal to 5 seconds. So that's the value of t. Once you have the value of time taken by the bullet to reach the highest point, you can easily calculate what is the height required to reach the highest point. So you can use the second equation of motion. Okay, so by second equation of motion, you can say h, or you can say h1 is equal to ut minus half gt squared. The negative sign here indicates that the bullet is going against the force of gravity, that is against acceleration due to gravity, and hence the negative sign. So let us go and substitute the values and simplify it further. So you will get 50 into the time taken here in this particular case. So they're telling for the first second, if you see in the question, it covers distance h1 during the first second. They're telling s is equal to 1 here. So here t is equal to 1. So 50 into 1 minus half, g is 10, okay, times 1 square. Simplify it, you get 50 minus 5, which is 45. So 45 meters is the value of h1. Okay, so that is 45. Similarly, try to relate the other quantity. Okay, so now find out the velocity. Velocity of the bullet at the end of 2 seconds. So you should find out. So by using the first equation of motion, you can write v is equal to u minus gt, which is 50 minus 10 into 2, which is equal to 30 meters per second. So you get the value as 30 meters per second. So therefore, this is going to be the value of the initial velocity for the last 3 seconds. I hope it's clear. Once you found out what is the change in velocity, in the next, that is in the last 3 seconds, if you try to find out, this 30 meters per second will be the initial velocity. Okay, so this will be the initial velocity, okay, for the last 3 seconds. So having this particular value, you can substitute and find out the height h2. So h is equal to again ut minus half gt squared. So u is now 30 into time is 3 seconds minus half, g is 10, and t squared is 3 squared. Simplifying, you will get 90 minus 45, which is 45 meters. So you get the value as 45 meters. So can you see h1 also was 45? I hope you observed that. This is 45, and you have found that h2 is also 45. So what do you observe from both the values? You can see H1 and H2 both are equal. They are the same. So you can come to a conclusion. This implies H1 is equal to H2. Both are equal. So your answer, your option is C. H1 is equal to H2. That's the value. Okay, so that's how you approach this particular question. Okay, I hope this aspect is clear. So we'll move on to the next question without any further delay. So we'll see the question number 4. So let me just write it down. Okay, here's the next question. A swimmer crosses a flowing stream of width d to and fro in time t1. To and fro in time t1. The time taken to cover the same distance up and down the stream is t2. Then the time the swimmer would take to swim a distance 2D in still water is. So, what is the time taken by the swimmer to swim a distance 2D is what is asked. So, you have different options here. The first option, T1 squared upon T2. Option B, T2 squared upon T1. Option C, under root T1, T2. And option D, T1 plus T2. So these are all the options that we have, and we will have to choose the right one. Okay. So let us see how to approach this question, how to solve it basically. So here you have a swimmer who is crossing a flowing stream. What do you mean by a stream? So basically, you have water that is flowing along. It can be a river. So the width of this river is taken as d, and the swimmer is swimming to and fro within the time t1. So t1 is the time duration wherein he is flowing, he is swimming to and fro. Okay, and the distance is also able to cover the distance up and down the stream is t2. To cover the distance up and down the stream, it is t2, and for to and fro, it is t1. Then they're asking, what time would it take to swim the distance 2D in still water? So in still water, how much time the swimmer is going to take? That is the question here. Okay, so we'll see how to approach this particular question. It's a different aspect altogether. So we'll see it. So for this, we have certain information that we need to know, some basics. Let's see. So let us assume let u be the velocity of the swimmer. So let u be the velocity of the swimmer and v be the velocity of the river flow. Okay. So we are having two different quantities here. We are taking u as the velocity of the swimmer and v as the velocity of the river flow or the stream basically. Okay. Then you can write T1 is equal to 2d upon under root of u squared minus v squared. Here, what is d? D is nothing but width of the stream. So d is width of the stream. Okay. And u and v already I have given there. And T1, I hope you know what the value of what is T1. So T1 is time taken for to and fro. Time taken by the swimmer for swimming for to and fro. Okay, for to and fro. That is T1. Similarly, we can also write, you can write T2 is equal to 2ud upon u square minus v square. So that's the value of T2. Now what is T2? T2 is the time taken by the swimmer to go to swim by the distance 2d, because twice the distance we are saying. So that is how you can write T2. Okay. So if T is the time taken by the swimmer to swim 2d in still water, then you can write, the time is nothing but distance upon speed, right? So we can write this as 2d upon u. So making use of this particular relation, we can say T2 into T is equal to, substitute the values children, 2ud upon u squared minus v squared into 2d upon u. So we have these values. Multiply and go for a simplification. We can write this as 4d squared. You can see that u is getting cancelled here. This u and this u can be cancelled, so you will get 4d squared upon u squared minus v squared. This is what we have. Okay, this is how you get the relationship, which means you can write T2 into T is equal to, what is 4d squared upon u squared minus v squared? Can we relate it here? Can we write it in terms of T2? Yes, you can, right? You can express in terms of T2. So we can write this as T2 times T is equal to T1 squared. On the top, you can see it is T1 the whole square. This is T1 entirely. If you square it, you will get back it. You will get it back. So that is why we are writing it as T1 squared. So what does T equal to now? So T is equal to T1 squared upon T2. And that's your answer. So you will get time as the ratio of the squares of time T1 and this T. Okay. So the answer is option A. So this is your answer. So that's how you approach this question. So step by step, I have explained. I hope this really helps. So approach by this particular method. So it's easy. Again, formulas, children, very important. We have written two formulas here for T1 and for T2. Both the times where the swimmer is swimming for twice the distance, and as well as to and fro. Both of them we have written here, and we are trying to relate them, okay, to get the new relation. Okay, I hope this aspect is clear. So with that, we'll move on to the next question. Question number 5. We'll try to cover, as many questions as possible today. Here we move to the next one. Okay. Yeah. A particle moving with uniform acceleration particle moving with uniform acceleration has average velocities v1, v2 and v3 over successive intervals of time. Over successive intervals of time t1, t2 and t3. Okay. The value of v1 minus v2 upon v2 minus v3 will be, so you have options here. First option, option A, t1 minus t2 upon t2 minus t3. Option B, t1 minus t2 upon t2 plus t3. Option C, t1 plus t2 upon t2 minus t3. And option D, t1 plus t2 upon t2 plus t3. So these are the options, children, that we have. Now when you have three different velocities over successive intervals of time, which is t1, t2 and t3, so they are asking us, each one of them in terms of the time variable. So that is what they are asking. So in terms of time, we are supposed to express. So how to express such questions in terms of time? So let us see that. Okay. How to express them. So there is a step-by-step approach for this also. Okay. So, okay. So for the first one, let's try to, visualize this particular concept. Okay. So let us say an object starts from point O. It reaches point A. From there, it further travels and reaches point B. And finally, it reaches point C. Now, initially, as it started from point O, the velocity is u. At point A, what happens to its corresponding, velocity? We know that v is equal to u plus at, so it is u plus at1. At point B, the velocity becomes u plus a times t1 plus t2 because it takes some more time to reach. To reach from O to A, it takes time t1. From A to point B, it takes time t2. Okay. From B to C, it takes time t3. So finally, what would be the expression for velocity at point C? You can write this as u plus a times t1 plus t2 plus t3. This is how you write the expressions for velocity for each and every successive point. Once you have written the velocities for each and every successive point, now we have to go and find out the relations for them. Okay, so finding out the relations for them. So what is v1? That is at point A. You can write this as u plus, just go for a simplification. So it is u plus 81 divided by 2. Okay, so we're dividing it by 2 because it's successive points. So what happens? You can write this as u plus 81 by 2. To simplify it, you will get u plus 81 by 2. Similarly, write the value for v2. So v2 can also be written as u plus 81 plus 82 upon 2. Okay, that is until point B. Okay, so you need to understand V1 is for OA, V2 is for OB, and V3 will be for OC. So similarly, V3 can be written as U plus 81 plus 82 plus 83 upon 2. So we are trying to generalize here. Okay, so once you generalize it, we can relate the equations, mark the equations, children. This is first equation, this is second equation, and this is equation number 3. By marking them, so what is V2 minus V1? Let's find out V2 minus V1, because in the question they are asking us, V2 minus V1. Okay, so we are writing what is V2 minus V1. Fine. So what is that particular value? Substitute and simplify it. You will get V2 minus V1 as A bar 2 times T1 plus T2. Similarly, okay, V3 minus V2. If you do V3 minus V2, you will get A upon 2 times T2 plus T3. So these are the values that you will be getting. Okay. Once you got the values of ratios of, the differences of velocities, you just need to find out the ratio now. Okay. So marking this as equation number 4 and equation number 5, we want basically 4 upon 5. What will happen if you do 4 upon 5? Just divide it. So V2 minus V1 upon V3 minus V2. If you divide the ratios, you know that A by 2 gets cancelled off and you will be left with T1 plus T2 upon T2 plus T2. Okay. So this is the value that you will be getting. So therefore, our answer is T1 plus T2 upon T2 plus T3, which is option D. So option D is our answer for this particular question. So you see how the question is. You will have to first visualize it, draw it, get the relations for each and every point. Once you got the relation, then we are trying to substitute in the given condition, which was V1 minus V2 upon V2 minus V3. So we substituted, we simplified them, and finally we found out the ratio. So this is the approach, children, to solve this question. It's a beautiful question. Okay, so only if you will try, you will get such questions. So I recommend all of you to practice on a daily basis. Okay, so go through it. So neatly we have solved. Let's go to the next question, children. This question number 6, the sixth question for the day. So we'll see the next question now. Okay, here comes the next question. It's a different model. Let us see how to approach this. Here comes the question. The relation between time t and distance x is given by the expression t equals ax squared plus bx. Okay, where a and b are constants. Where a and b are constants. The acceleration is. What is the acceleration? We will have to find out. I'm giving you the options, children. First one, 2ab squared. Option B, minus 2ab squared. I mean 2ab cubed, children. Sorry about it. It's minus 2ab cubed. Option C, 2b v cubed. And option D is minus 2ab v squared. So this is the fourth option. So you have four different options here for the given question. So they have given you an expression of time. You can see the expression is 2t is equal to ax squared plus bx, where a and b are constants. Okay. Now based on this, we will have to find out what is the value of acceleration. So how do you approach this particular question? So first we try to find out what is the velocity and how do we do that. To calculate velocity, you know that velocity is a function of displacement. Okay, you know, since velocity can be written as dx upon dt, which is the rate of change of displacement, so I can write everything in terms of displacement. So let me bring in the displacement term basically here. Okay, so differentiate both sides with respect to t. You differentiate, children, the expression. So differentiating the given expression, both sides with respect to t. So differentiate with respect to t on both the sides. So what happens if you do that? You have t is equal to ax squared plus bx. This implies you will get 1 is equal to 2ax plus b. Okay, you will get it like this. So 1 is equal to 2ax plus b if you are differentiating with respect to t into dx upon dt. So once you get a relation like this, you know that velocity is the rate of change of displacement. So you can go and express that as 1 upon 2ax plus b. What happens then? You take it to the numerator. You can write it as 2ax plus b, the whole inverse. Okay, that is how velocity can be expressed. Okay, so once you express velocity, children, now you go and find out what is acceleration. Acceleration is the rate of change of velocity. So can be expressed as d by dt of 2ax plus b, the whole inverse. And you just differentiate it. You will get it as minus 2a upon 2ax plus b, the whole square, times dx upon dt. So I'm differentiating here, applying the chain rule. So finally, you get acceleration is equal to minus 2ab squared times v. Okay, so this is 2a v squared times v, which is equal to minus 2a v cubed. So we finally get acceleration is equal to minus 2a v cubed, and that's your answer. So that is the value of acceleration. Okay. So the answer is option B. 2a v cubed is the answer. Is that clear, children? So that's how you solve this particular question. So with that, we'll move on to the next one. So we'll see one more question, one last question. We'll see question number 7. One last question, children, before we wind up for the day. Okay. A particle moves a particle moves a distance x. Okay, a particle moves a distance x. I hope I'm audible. In time t, according to the equation, x is equal to t plus 5 the whole inverse. Okay, the acceleration of the particle, is proportional to, so what is the value of acceleration proportional to? That is what they are asking in this question. So we look at I'm giving you the options. It is velocity the whole squared. Okay. Option B, velocity the whole to the power 2 by 3. Option C, distance whole to the power squared. And option D, velocity whole to the power 3 by 2. So we'll see how to solve this particular question. So in this question, the particle is moving a distance x in time t according to the given relation. Okay. So we'll see how to do this question. They've given you a particular relation in this question. Fine. So here, distance squared, let me make this as distance cubed. Okay. Yeah. So like this, you have different options, children. So we'll see how to solve this particular question. So here, you know that velocity v is equal to the rate of change of displacement, which is dx upon dt. Okay. So I'm substituting the value. So I will get d by dt times t plus 5 whole to the power minus 1. So children, you differentiate this, you will be getting the value as minus t plus 5 whole power minus 2. So acceleration I am substituting as the rate of change of velocity, which is dv by dt. That is d upon dt, differentiation of time with respect to v, which is minus of t plus 5, okay, whole to the power minus 2. So you differentiate this chain rule, children, you will get 2 times t plus 5 whole to the power minus 3. So that is the value of acceleration. Okay. So once you got this relation, what will you get from equation? From the equation, you can write this as from the previous equation. Okay, from the previous equation of velocity. So let us mark that particular equation as 1 and this equation as 2. So you mark them, you know that from equation 1, you can write v to the power 3 by 2 is equal to minus t plus 5 whole to the power minus 3. Okay, so you know that this implies acceleration is equal to minus 2 times v to the power 3 over 2. Once you get this particular relation, you see that acceleration is directly proportional to velocity whole to the power 3 by 2. So it's proportional to velocity whole to the power 3 by 2. So this is how you get the relation for acceleration, okay, which is proportional to the velocity. So here acceleration of the particle is proportional to velocity whole to the power 3 by 2, and here you have your answer as option. So you can see that it is option D. So this is how you find out this particular solution. It's by differentiation. I hope it is clear. So we have seen different aspects today. Okay. So with this, we will wind up today's lecture. Any doubts you can ask, children. I will share this, notes, with sir. So it will be posted in the WhatsApp groups as well. All right. So thank you one and all. So looking forward for the next lecture. Okay. Until then, bye bye. Take care. Yes, uncle. So I think we can wind up. Hello. Hello. Yes, uncle. I hope we can wind up. It's done for today. Yeah. Am I audible? I'm not able to hear you. What you're saying. Yes, uncle. So we are done for today. So we can wind up here. Yes, uncle. I'm audible. I hope I'm audible to you. Yeah.